Hi, my name is Chelsea Thompson. I am a research scientist and science communicator at the NOAA Chemical Sciences Laboratory, and I am a contractor for the University of Colorado working at NOAA in support of NOAA's mission. Getting to this career was definitely not a straight path. It was a very, very windy path. When I was in high school and college trying to think of what I wanted to do, I didn't even know that NOAA existed. I didn't know what they did. I've never heard of atmospheric science. And I actually went into forensic science originally because I was really interested in solving puzzles and using science to solve puzzles like that. And it wasn't until I got into graduate school and I had to look for a professor to work with that I met the man that I chose to work with, Paul Shepson, who is an atmospheric scientist. And he had his own airplane and he flew around in Alaska measuring the air. And I thought this was the most exciting thing ever. And so I decided to continue working with him. And my background education-wise is that I have an undergrad in forensic chemistry, and then I got my PhD in analytical chemistry. And from there, I ended up hearing about NOAA through my work and moved out to Boulder because that's where I wanted to be. And I ended up getting a spot at NOAA. And everything NOAA specific has been on the job training though. What really got me interested in doing atmospheric science when I heard about it is that I love the outdoors and I love science and I love solving puzzles. And so my interest in forensic science sort of carried over into this atmospheric science realm because it's really doing a similar thing in that you're measuring small amounts of something, air pollutants in this case, in a large area, so like in all of the air that we breathe. And that's really similar to what we do in forensic science as well, where you're measuring a trace amount of like blood, for example, or drugs in a larger matrix. So a little bit of drugs and a large amount of blood, and so you're trying to solve a puzzle that way. And so the skills and the interests sort of actually parallel each other in both of these fields. But in atmospheric science, I was able to be in the environment and do something outside and fly in airplanes and do science at the same time. And I thought that was just the most amazing thing. I couldn't believe that we were actually getting paid to go out to these really amazing field locations all over the world and use science to measure what's happening. I mean, I really feel that scientists now are what we have in terms of the last great explorers. Like, we're the ones that are exploring the rest of the planet and trying to find out all its mysteries through science. My typical day is really not as exciting as it can be. So we do a lot of field projects, which is what I love about this job, is that we can go out into the field, fly in research airplanes or go on research ships and do measurements out in the field. And that's the most glamorous part of the job. But that's not every day. These projects are very large. They take a lot of people and a lot of time to get them together. And so that really only happens maybe once a year, maybe every 2 years, depending on the size of the project. And so the rest of the time, we are doing a lot of work in analyzing all of the data and the measurements that we've collected. There's a lot of computer programming involved, a lot of data analysis. We often write our own computer codes to analyze that data. And then we do a lot of interpretation. What does this data mean? What is it telling us? Write it up into papers, publish those papers, present at conferences. Sometimes we do laboratory work as well to try to understand our observations better and try to replicate like a chemical reaction perhaps that we saw in the atmosphere. We'll try to replicate in the lab. So we'll do some laboratory work as well. But a lot of it is, computer work and number crunching and writing papers when we're not in field. One of the things that I'm asked a lot by students is what sort of background or education that you need to get into this job. And it can be really intimidating when we talk about going on airplanes or ships and building instruments to measure things in the atmosphere, that a lot of people don't know how to do that. And I want everybody to know that we don't expect you to. These are not things that you're ever going to learn in school in your classes. What we're really looking for is that you have a good solid background in the STEM fields. So your chemistry, physics, engineering, statistics, computer programming, and things like that. These are the things that we're looking for. And then, everything else as far as learning how to build an instrument, I didn't know how to do that when I came here either. And you learn that on the job. We teach you that here. We have a lot of people that have been doing this for decades and are experts in the area.